Okay, so then I'm going to take him and jumper him back to the power bus. And there we go. So what I've got is the power comes in, but it only comes into this spot here by the LED. So when I have power, the LED is always on if I have my battery connected. So if the battery is connected, the LED is always on. I'm going to put this over here. See, there you go. The LED is always on. If I disconnect my battery by, say, taking the clip off, that goes away and nothing works, obviously. But if I put the battery on, it just tells you I have a battery, right? So now when I press the button, I don't have any power to my bus because it's going over here to the switch. So when I press the button, it connects the power to the bus and lights up the LED. So there's a lot of concepts there we're trying to get across to the kids, but we're going to work on this again. We're going to try to get everybody to get this built and understood before we move on, because when we go to integrated circuits, we need to understand kind of the electron flow. So the key, I think, here is the electrons exist in the battery. The battery is designed to provide pent-up electrons, also called voltage, 9 volts, and when you connect those, the electrons move from one side to the other, one terminal to the other. So they come out the red, move through whatever circuit you have, and then back through the black. So right now, see, the black's connected, the red is not, nothing's happening. So when I plug it in here, the electrons move through the LED, the resistor, and back through the black to the battery, and then they work. It creates the LED lighting up. Now, I jumpered it over to the switch, so the electrons can't get through the switch because I have to push it down to allow them through. So right now it's just the LED, which is our basic circuit. So now when I push the button, it connects inside that switch, then the electrons are allowed to move through the circuit here, and it lights up, right? So that's the first key concept, is the movement of the electrons through the wires, through the devices, which are the LED and the resistor and the switch and stuff. The electrons move through them back to the battery, and when they move through them, things happen, right, that we design. So if you have this rocker switch, what I can do is I can disconnect. Where would I disconnect it? Let me disconnect it here at the battery. I take the rocker switch. It doesn't really matter which way I do it, but I'm going to clip the black part of the rocker switch here. I'm going to take another alligator clip, a yellow one, and I'm going to clip it here, and then I'm going to clip this to the battery. So now I have everything hooked up, nothing's happening, not even the power LED is on, and that's because it's running through this switch. You can see it here. Let me move this stuff up a little. You can see it here. So there's the switch, right? So with lots of wires, I come out of the battery. The red out of the battery goes to the yellow clip. The yellow clip goes to the switch here. Then on the other side of the switch, it goes back to the red clip, which then runs over to the red here. So now when I push the button, it lights up, so now it connects. So now I have two switches. I have the rocker switch that connects the battery to my main circuit, or to my indicator circuit there, and then I have this switch which connects it to the 7-segment display. So what we're going to do, once we get this down, we'll have an IC that actually allows you to, when you press this, it'll count. It'll go 3, 4, 5. Right now it's just set up physically to do a 4, right? So that's pretty much it. If you have any questions, you can send me an email, but if you want to, and I apologize again for the quality of this. This is the first time I've done one of these, so I know the camera isn't straight, but if you watch it, maybe if you watch it 100 times, you know, something will become clear. But Any questions, send me an email and I can at least talk to this. I'm going to be out for the next class. I'll be in China actually. I'm leaving in a couple hours. But the substitute will be able to help them with their parts and fill out their materials, make sure they have everything. So we got one more class to try to get this solidified, and then we will move on to the next step in the design of our robots. So, okay, well, thank you.